Okay, so here we are for part 2 of this metal reactivity series, and it's been a little over an hour since we started this lab, and I just wanted to show you some of the reactions that took a little bit longer. So first, I'm going to use my tweezers for safety because I'm going to pick some of these up because they're kind of neat. I'm going to use a magnifying glass so you can get a better visual of what's going on here. So here we have, this is zinc with water, and you'll notice that there are, let me get that glare off of there, some bubbles. So that means that there is some sort of reaction happening where the gas is being released, okay? And if we go over to the diluted sulfuric acid, there's several bubbles in there. They're a little bit bigger, they're slow moving, but again, gas is being released. This one in the copper sulfate, lots of interesting things going on there. Lots of black precipitate being made, and it's actually so much that it's actually sticking out, and if I take the tweezers, it's squishy. It's literally the black stuff is squishy and kind of gross. There's still a little piece of zinc in there, but it looks kind of like yucky, gross now. And look at all that black yuck in there. Ew. It's all over my tweezers too. So let's move on to the copper. So the copper in the water still kind of looks like copper. There was a bubble on there earlier, but it released itself before I made this video. Here is the copper in the sulfuric acid, and I'm going to pull this out so that you can compare it. So if we can put it onto the control, you can kind of see that the luster is a little bit different. It's just got some of that, it's a little bit lighter in shade, okay? And in the copper sulfate, it's just kind of dulled out a little bit. It's almost blue. You can see it's blue. So we're going to say that copper probably doesn't react with copper sulfate very much because it's one of the ingredients to make copper sulfate, right? Copper sulfate. We're going to move on to aluminum. If we take a good look at the aluminum here in the water, I don't know how well you can see that, but there are bubbles and there's tiny little pieces of black starting to form in there. So there's some precipitate being made, and there's a tiny slow reaction happening. If we move over to the diluted sulfuric acid, there's some tiny bubbles on there, not a whole lot. But when we go over to the copper sulfate, the liquid in there isn't even blue anymore. It's kind of like this gray mush, and the aluminum keeps trying to float. There's bubbles forming in there and lots of little fizzing starting to happen, and it's really starting to get discolored. So when I take this out, it's really kind of cool if I can get it. Can you see that it's actually starting to turn red? How cool is that? There's some redness happening there. All right, so then we move on to the iron. So the iron in the water, as you can see, there is one great big bubble on there, okay? We move to the diluted sulfuric acid, lots of bubbles, so there's lots of gas being released now. We move into the copper sulfate. The liquid isn't bright blue anymore like it is up here. It now looks kind of murky. And when I take the iron out, it's also covered in smoosh, and it's a layer of red, and it's the iron, that's iron oxide that's in there, that it's in there now. It's red. It's kind of like rust, and it definitely doesn't really look like the iron control anymore. So we'll just stick that guy back in there and see what else he can do. Now with the magnesium, it's not going as strong as it used to, but that's because the reaction was fast and furious. So it was definitely more reactive. And if a reaction is going really fast, that means it's going to end faster than others. So when we look with the water, it's floating now, which means there's gas bubbles in there. Where am I at? Magnesium. There's gas bubbles underneath of it, helping it float. So we know that there's a reaction happening with the water. When we move over to the sulfuric acid, this is the one that was fizzing like Alka-Seltzer. And that fizzing has stopped, but it's still producing lots of little bubbles in there. When we move over to the copper sulfate, it looks really kind of gross in there. Let's see if I can get that to zoom in better for you. It kind of looks like pond water. That's what we kind of described it in class. There is still a ribbon of copper sulfate, of magnesium ribbon in there. And it's got kind of this blue tinge to it. It's kind of hard to see on the camera. But there's definitely lots of brown and yucky looking stuff in there. Okay. If we move down to tin, okay. Remember tin, it didn't look like a lot was happening, but if we look at it now, tin's got a couple of bubbles on it, nice big bubbles, which shows a nice slow release of a gas. So if that gas is being released, that means there's things happening to release that gas. When we look at it in the diluted sulfuric acid, we got some glare here. Let's see if I can get that off. Doesn't look like a whole lot's going on. Take it out of there. It looks kind of like it's control, maybe a little bit shinier than the control, but there's not a lot of visual difference. But when we look at it in the copper sulfate, it's actually got this weird film on top. So the precipitates are floating, and it's got a color change. It's not that silver. So when I compare the two, okay, so that's in there. So there's lots of change. And what I'm going to do is I'm going to go ahead and leave this overnight, and we'll check back in the morning and see what happens, okay?